Hello everyone, this is Brendan and this is going to be a math video teaching you how to convert from logarithmic form to exponential form. So what we can see here is over on the right hand side I've provided you with the basic logarithm formula. Log base A of B is equal to C. We call this A value right here. This is the base. We call the B value the argument. And C is just the other side of the equation. So what we're going to do is show you how to take a few progressively more difficult logarithmic equations and convert them properly into exponential form. And what I wanted to point out is, as I look at this y equals log base 2 of 8 problem, well, what is each term here? Well, what I can see is that my 2 value is my base. It's essentially the a term from this equation over here. My 8 is my argument. It is my b term. And y is on the other side. That is my c term. So what I want to do when I convert this from logarithmic form to exponential form is I'm simply going to write my a value, which is 2. I'm going to raise it to y, which is my c value, and I'm going to set it equal to 8, which is my b value. And that's pretty much how you do it for a very basic logarithm form problem. The next question that we're going to go over is a little bit more complicated because it's going to have this coefficient on the logarithm. Well, what we have to do when we see a problem like this is we simply have to isolate the logarithm before we can switch it to exponential form. So what I want to do is make sure that on the left side of my equation, or the right side of my equation, wherever the log is, I only want to have the log, its base, and whatever the argument is. So what I have to do here is divide both sides by 4 and go ahead and take that 4 over to the other side. So I'm going to end up with y over 4 is equal to log base 5 of x. And what I can see now is that I have my base and my argument as the only two things on the log side of the equation. So I can now define my terms as a, b, and c. Pick another color here. So my 5 value is my base, so that's a. My x value is my argument, so that's b. And this y over 4 is the other side of the equation, so it's my c value. So this equation would become 5 raised to the y over 4 is equal to x, and that's how we would solve a problem like that. Now, looking forward to the next problem, what I can see is that my y value would be my c term, my 3 value would be my a term, it's my base, and my x minus 7, this whole thing is the argument, so this whole thing is going to be the b value. Once something is in parentheses, I'm going to emphasize these parentheses right here, that basically tells you that it's the argument. If it's inside of the parentheses, it's totally fine. So what I'm going to do is I'm going to take my a value, 3, I'm going to raise it to my y value, and I'm going to set this equal to x minus 7. And that's going to be my solution to that problem. Looking forward to the next problem, I see that I have a lot going on, so this is a real challenge problem. I have this -8 coefficient, I have my base 7, I have my argument 2x plus 3, and then I have this vertical shift of 1 down. So what I have to do in order to convert this from logarithmic form to exponential form is, remember, I need only my log, its base, and its argument on one side of the equation. So in order to isolate this, I'm first going to add 1 to both sides. So I would have y plus 1 is equal to -8 times log base 7 of 2x plus 3. Now, again, the reason I'm using the colors here is to help you see where the base is and help you see where the argument is. My base is this 7 value that's in this orangish color, and my argument is this 2x plus 8 value, which should in fact be 2x plus 3, because we're not changing the problem. And so what I can see next is I still have to get rid of this negative 8. So I'm going to go ahead and divide both sides of this equation by negative 8. So what I'm going to have after I do that is y plus 1 over negative 8 is equal to log base 7 of 2x plus 3. And now we can see that on one side of the equation, I solely have my base in the 7 and my 2x plus 3 with the logarithm. So it is at this point that I can go ahead and identify what my a term is, what my b term is, and what my c term is. 7 being my base is going to be the a term. 2x plus 3 being my argument is going to be the b term. And y plus 1 divided by negative 8 is going to be my c term. And once I have all that information, I can go ahead and write over here 7 raised to the y plus 1 over 8, and I'm going to go ahead and pull the negative out here, is equal to 2x plus 3. And that's how you would set up that problem. Now, please try this last problem before I give you the solutions. Okay, I'm going to go ahead and work out the solutions for this one. So first I'm going to subtract 5 from both sides. I'm then going to divide both sides by 2. I'm going to go ahead and change colors here just to emphasize that I have my log, my base, and my argument all on the right-hand side. At which time I can go ahead and switch this formula from logarithmic form to exponential. And there you have it. That's how we do some of the most complicated conversions from logarithmic form to exponential form that you're going to see in your Algebra 2 or pre-calculus course maybe. Please feel free to subscribe to my channel.